Alright, let's solve problem F16-21. Now this is the same problem we solved as F16-15. This time they've added an acceleration. So a fixed gear rolls on rack B. At instance shown, the center of gear moves a velocity of 6 and an acceleration of 3. Determine the acceleration of the gear and the acceleration at point A at that instant. Now, from problem F16-15, we're going to use omega equals 20 radians per second. That we already solved for. Now, we used the IC, the instantaneous center of zero velocity, down here at, we'll call it B. Okay, but that's not the center of instantaneous zero acceleration, because as you notice right there the velocity is 0, but as it rotates up it will immediately have an upward velocity. So the acceleration there is not 0. So we're going to start out using the acceleration equation of AB equals AA plus alpha R cross R BA minus omega squared RBA. So there's the equation out of the book. But we're going to go between this point, which I'm going to call B right there, and O. So I want to solve AO equals AB plus alpha cross ROB minus omega squared ROB. So let's see, what do we know so far? So AO equals 3 in the I direction. Alpha is equal to alpha in the K direction, negative alpha in the K direction. Just rotating that direction. ROB is equal to, from here, we're going from B to O. So we're just going straight up a 0.3, the radius of the inner gear. So 0.3 in the J. And omega we know is 20 radians, and then ROB we know. So let's first solve for that cross product right there. So alpha cross ROB is going to be IJK, IJ. Alpha is negative alpha. ROB is 0.3 in the J. So that limits us to that. So the cross product is negative 0.3. Oh, negative because we're up. Negative for that makes it a positive. Negative and negative. 0.3 alpha in the I direction. So substituting everything into this equation here, we get 3I for negative I. AB. AB we don't, we do know. AO is 3. No, AB we don't know. So that's just AB. But we know it's in the J direction because it's going to be accelerating up. Okay, and then we want to cross that with no, not cross. We want to add to that because we're right there. We want to add to that 0.3 alpha in the I direction, and then we want to subtract off 20 squared times ROB, which is 0.3 in the J. Okay, so separating the I's and the J's, now we have 3 is equal to 0.3 alpha. Now what we're trying to get out of this is alpha, because once we know alpha for the gear, then we'll go from O to A and do the same thing over again. We could also solve for AB. We really don't need it, it's not asked for, but 0 is equal to AB minus 120 the 2 J's. And we could solve for AB equals 120. But what we're really interested in is alpha equals 10 radians per second squared. Okay. Now that we got that, we're going to do the same thing from O to A. So AA is equal to AO plus alpha cross RAO minus omega squared RAO. Okay, so now AA is what we're trying to find. AO is 3 in the I, same as there. Alpha cross RO, we'll have to do our cross product again because now RAO is equal to, from A to O, is equal to 0.6 in the I. And then omega is still 20, and RAO is that again. So let's do the cross product here. So IJK, IJ, and alpha is still 10. And RAO is 6.6 in the I. So the only thing that's going to be consequences there. So we got 6 in the J. So putting everything into this equation here, now we have AA is equal to AO, which is 3 in the I, plus the cross product, 6 in the J. Let's see here, that should be negative. This is a negative 6. R from O to A. From O to A. So this is negative, and this is negative, and this is negative. And this is negative. And then plus 240 in the I. So AA is 243 in the I minus 6 in the J. And that would all be in meters per second squared.